Hello, and welcome to my YouTube channel, where you will learn all kinds of cool and interesting things. Probably not, but who cares? So a couple weeks ago, my dad built a solar collector. And I've always kind of thought solar collectors were pretty cool. Um, Renewable energy, solar energy, whatever, what have you, is kind of an interest of mine. And I got pretty excited when he told me about it. And I thought it'd be cool, as a project of my own, to build a temperature-controlled fan that would circulate air through the solar collector and into the house or a garage or wherever it is you're trying to circulate warm air from a solar collector. So that is what this video series is going to be about. The steps I took and the approach I took to build such a device. So let's get started. Let me see if I can switch the camera around here. Oh, it doesn't look like I can do that. Alright, so I got the camera flipped around finally. And for those of you that don't know, this is kind of the general idea behind a solar collector. We're collecting cold air down here, and we're ultimately going to have warm air at the top of this thing. And there's different designs and different approaches on how to achieve this. But one of the most popular ones is to take soda cans and cut out the tops and the bottoms and stock them together and paint everything black. And when the sun shines on these multiple columns of cans, warm air is circulated up through them and ultimately ends up in this top chamber up here. Now, for this project, what we're going to do is we have a fan, which is going to be located on the inside of this device, at the top, at the exhaust. I guess you could call this the exhaust. And our electronics are going to be located roughly right here, and it's going to monitor temperature and it's going to control the fan and all these kinds of things. So that's basically the rough idea here. So first things first, where do we start? First thing we need is power. So it's fairly easy to get 12 volts DC. We can get 12 volts DC from a small solar panel. We can get it from an AC to DC power supply, relatively inexpensive. 12 volts is also required to run our fan, so it's kind of a requirement, and it's very easy to get. However, our electronics, in this case, are going to be running on 3.5 volts. Okay, so the first part of our design here is to step down 12 volts to 3.5 volts. So how do we do this? The main component here is the LM317 voltage regulator. And there's plenty of documentation on Wikipedia on how to use the LM317. But essentially what happens is we've got a 12 volt source. We've got, and this is on a pin. In fact, here is an LM317 right here in physical form. So it's got an input pin, an output pin, and adjustment pin, which we see here on our schematic. And our adjustment pin, this is what tells the device how much voltage to supply on the output. And that's determined by this voltage division circuit right here. Okay. For those of you that aren't aware, if you've got a voltage, let's say 5 volts, and 2 equal resistors, okay, measuring in between those 2 resistors is going to give you exactly half of the voltage up here. So if we have a 1K resistor here and a 1K resistor here, you'll end up with 2.5 volts. So by selecting different values for this resistor and this resistor, you can vary the voltage that you read on this adjustment pin, and that's how internally it's able to output different types of voltages. And this can output, I think, anywhere between 1.9 and I don't know, like almost like 19 or 20 or some voltage like that. 24 volts maybe, I think. So ultimately, once we go through this process, we end up with 3.5 volts, and that's it. And of course, all this is safely decoupled So we got a 100 nanofarad here to ground, and a 100 nanofarad capacitor to ground on this voltage as well. So, all right, so I put together a quick prototype of the schematic that I was showing you earlier, incorporating the LM317. And what we've got here is we've got a power supply that is outputting 12 volts, and that voltage is coming in here, so we've got positive and negative. And this whole rail, this side of the rail is all positive, and this side of the rail is all negative, all up and down. So, I don't know if you remember, but on the schematic there were two resistors, resistor high and resistor low. One was a 1K and one was a 1K5. Now, I don't have a 1K5 resistor. I only have 1K resistors and 560 ohm resistors. So RH, or resistor high, is a 1K resistor, and resistor low is a 1K resistor in series with a 560 ohm resistor, and that gives me roughly 1K5. So I've got 12 volts coming in on the input pin. We've got the output pin there in the middle, and then we've got the adjustment pin, which is connected to this voltage division circuit with these resistors. And this orange wire here is connected to the output pin. And just for a sanity check, what we're going to do is I'm going to unplug this just slightly so I get my probe in here. And we got our handy dandy meter, and it's reading 12.14 volts. Now we're going to take this orange wire, we're going to measure this, and we get 3.452 volts. What do you know? We have stepped down 12 volts down to 3.5 volts. Perfect.